module 1. So I think we just have a short session. So if you have watched the coverage that we have is the second recorded lecture that I have posted, the link that I have posted in Canvas about the periodic table. So we're talking about the trends in periodic table. So I think later on, if you take the quiz, you have to prepare a copy of the periodic table so to help you in some of the questions. So these are the elements in the periodic table and the time when they were discovered. So as you could see, there's some of them are known in ancient time, like the one that you can see here, and some with discovered around the Middle Ages, to 1700, the green one. Okay, others are discovered later, and the rest were just discovered this century, especially the what we call the one that can only be prepared synthetically. Okay, so in our previous discussion, so we talk about the orbitals being filled up by electrons and the sequence that they have there on how the orbitals are being filled up. That's what we call the electron configuration. So at the most stable state, we follow the so-called ground state electron configuration of the element. So we have done this in our what we call previous synchronous class. Okay, so if we're going to look at this electron configuration here, so as you could see, this is the s orbitals. These are the p orbitals, the d orbitals, and the f orbital. Okay, so if you're going to look at this, there's some sort of what we call a pattern that you follow. So if you're going to start from the beginning, so if I'm going to what we call do this. So here, that's the ns1, ns2, so the n is the principal quantum number, the value of that n is here. Okay, at least for the s and the p. But if you go with the d, okay, the rule that we have there, the n value that you have there for the d is always what? N minus 1. So this we can call as 3d1, 3d2, 3d5, 3d10. Now for the f orbital that we have here, so this is 4f. If you're going to look at this, so we follow f as n minus 2. So you see n is equals to 6 here. So minus 2. So the f starts at 4. Okay, so I think you should still know this from the previous one because I think I have some question asking you for the electron configuration later on. Okay, now what happened? If we're going to characterize the stuff that we have here, so we could say the s and the p orbital are the representative elements, and that includes the noble gases. Okay, and the d orbitals are what we call the transition metals, including the zinc, cadmium, and mercury. And this one here, we call them the lanthanides and the actinides. Okay, lanthanide for the lanthanum and actinide for actin. Okay, and if you're going to look at this electron configuration, we can also consider the changes that happen, whether you gain or lost electron. So for instance, when you have sodium, okay, in its ground state, this is how it looks like. Now, what happens if you knock out one of the electrons? So you're going to lose the outermost electron, and you have an electron configuration that is similar to your what? Ano Ne? Noble gas. Okay, so if you have calcium, you knock the two, or you remove the two outermost electron, so you form a calcium ion. So its electron configuration is similar to the argon. Okay, so if you have an aluminum, you knock the three outermost electron there. Its electron configuration is now similar to what? The noble gas configuration. So atoms, they lost electrons, so that cation is a noble gas outer electron configuration. Okay, so for instance, if you have H or hydrogen, that's 1s1, So if you're going to add, so you have a negative sign here, so that means you're adding an electron. So the electron configuration of H minus is similar to helium because you have 2 electrons there in the orbital. So if you have a fluorine, okay, so if you add 1 electron from the fluorine neutral charge to become negatively charged, so it becomes what we call similar to the noble gas configuration. So here, if you're going to look at this, atoms can lose or gain electrons to become or to have an electron configuration similar to what we call the noble gas. And in the next module, when we go with bonding, okay, it's following the so-called octet rule. So as much as possible, they said atom become more stable if they have the same electron configuration as the noble gas, because the noble gases are what? They are stable elements. That's why you call them noble gas. Just like the noble people, they don't interact with ordinary people. Okay. So if you're going to look at the cations and anions of representative element, this is how they look like. So +1, +2, +3, -1, -2, sometimes -3. So whenever they have this, what we call charge, the electron configuration is the noble gas before, if you have the positive charge before them, or the noble gas after, if you have a negative charge here. So if you have oxygen, you become O2 minus, your electron configuration will be similar to neon. Okay. Now, if you have the same electron configuration, you have the same number of electrons, you say they are isoelectronic. So we could say here that the sodium ion is isoelectronic with neon. It is isoelectronic with aluminum 3+, okay, and is isoelectronic with fluoride. Why? Because they have all 8 electrons. They have the same number of electrons, and they have the same ground state electron configuration. Okay, so the same thing we could say that the oxide and the nitrite, it is isoelectronic with those mentioned species. Okay, so all of them are what we call isoelectronic. So who knows, you may ask the question, which of the followings are isoelectronic with a certain element? Mas maigi ng handa. Okay, so you may ask the question is, what neutral atom is isoelectronic with H minus? What will be your answer? So H minus, it has what? 1s2, because you have an extra negative charge. So from H, which is 1s1, so you add a negative, so that means +1 electron, so you get 1s2. So that is equals to helium. So we could say H minus is isoelectronic with helium. So you might be asked a question like this in the exam. Okay. Now you can have the electron configurations of these cations of transition metals. So if you're going to look at here, if you see, whenever you have a transition metal, whenever you remove the electron, okay, it is the electron coming from the s orbital. Okay, not from the d. Because the s orbital, they said, is the more outermost, the s and the p orbital. So if you have an Fe, it becomes Fe2+, so that means you remove 2 electrons, so you lost the 2 electrons in the s orbital. If it's 3+, so that means it removes first the 2 electrons from the s, and then the one from your what we call p orbital. So it's always the s orbital electron that is lost first in transition metal. Okay, now what is this so-called effective nuclear charge? So when you're talking about effective nuclear charge, that's just the positive charge felt by an electron. So if you're going to look at the effective nuclear charge, this is just equals to Z minus sigma. Okay. So C there is your atomic number. Okay. And this thing here, that's what we call the shielding constant. Okay. So if we're going to look at the trends of your effective nuclear charge, okay, it is just C minus the number of inner or core electrons. So if you're going to look at the set value here, okay, from sodium, magnesium, aluminum, silicon, what are they? They're moving from left to right. Am I right? So just to check if they're moving from left to right, we can go look a periodic table that we have here. So that's what? Sodium, magnesium, aluminum, silicon. So if you're going to look at there, look at the atomic number. They are increasing. Okay. Now, the core that you have there, that's what we call the inner or core electrons. So if you're going to look at this, these are this. So you're moving from here, here, until here. So that means they have all the same core electron. The one that is changing is their outermost electron. So as you can see, it's the same there. So if you're going to look at C, which is the atomic number minus the number of inner or core electrons, so you have the effective nuclear charge increasing. Okay, and if you're going to look at the effect of this in radius, so this is what you see. As the effective nuclear charge increases, what happened to the size?
It decreases po, sir.
Okay, so it decreases. So here you can look at maybe from left to right, the trend of your radius decreases, or atomic size as they use in other books. So if you're going to look at the effective nuclear charge from left to right, it increases. From top to bottom, it decreases. Okay. Now you may ask yourself, why is the effective nuclear charge it also increases here from top to bottom. Okay, because you are introducing, okay, a new set of electrons. Now here, from here, usually ito yung effect niya eh. Z minus the inner core. But going down, it's set equals to C minus the shielding. Okay, so the shielding, that is the one caused by the inner electron. It's just that, imagine in a parade. So you are in the outermost. So the people in front of you will shield your view. Okay. So it has an effect on this, what we call set. So how does it affect the atomic radius? So sometimes you have to look at the convention, but I think the best way to describe atomic radius is the distance of the outermost electron to the nucleus. Okay. And if you're going to look at the trend here, this is the only thing that you need to know. Okay. So atomic radius increases from top to bottom. And left to right, it decreases. Another thing, why it decreases from left to right, what happens from left to right? You have the positive charge, you have a negative charge. You have a positive charge, you have a negative charge. So the more positive charge, the more negative charge. Negative attracts. So the greater the attraction, the smaller the size. Does that make sense? Now, from top to bottom, you're increasing. Remember the definition of the principal quantum number, the one that we have in terms of the size. So as you increase the n, okay, you have a new energy level. So what happened there? It becomes larger. So from top to bottom, okay, the atomic radius or atomic size increases. So the question that you will be asked, you're given a set of elements, and then you are asked which has the smallest or which has the largest atomic size or atomic radius. So dapat yung mga tanong na to, sure points na sa inyo. These are the easy ones. That's why I told you, before you take the quiz, make sure you have a copy of the periodic table. Okay, so if you're going to look at the trend, so this is what we call LIF. So this is within a period. So kita nyo from here, malaki tapos liliit. Tapos malaki ulit, tapos liliit. Kaya kita nyo dito, okay? Left to right, it goes down. And then top to bottom, ito yung top to bottom. It goes up. Now, you can also look this atomic radius with the so-called ionic radius. So ano yung ionic radius? So let's say you have an atom. So pwedeng mag-form ka ng what? Positive ion or negative ion. So paano nangyayari yan? When do you form a positive ion? When?
Pag nagbawas po ng electron.
When you remove an electron. So when you remove the electron, what do you think happened to the radius? Will it increase or decrease? Okay? Since nawala ka ng electron, most likely, bababa siya. Okay? Doon naman sa negative charge, usually what?
You gain an electron po.
You gain an electron. So pag nag-gain ka ng electron, remember, the electron are responsible for the volume. Nasa outer part siya. So if you become what we call an anion, your ionic radius increases. So that's what you observe here. Okay. Now, if you're going to look at this, if you want to compare the ionic, the atomic radius with the ionic radius, so see what happened here. So when they become cation, the size decreases. Tama ba yun sa ano natin dito? Kapag naging cation siya, mababa yung ionic radius niya. So you could see the cations there has lower atomic ionic radius compared to the atomic radius. Now, if you're going to look at the anion like this one, when they gain electron, their size increases. Okay. So if you're going to look at this on what is happening if you form a salt or an ionic compound, so you have here lithium and fluorine. So what happened? This loose electron, and usually that electron is gained by the fluorine. So when it loses an electron, it becomes an Li+, so it's just so small. Okay, the electron gained by fluorine, so what happens to the fluorine? It becomes fluoride. Now the positive and the negative charge there, that's an electrostatic attraction that is formed. So nagkakaroon ng what we call ionic bond. So cation is always smaller than atom from which it is formed, and anion is always larger than atom from which it is formed. Okay ba? Okay, so if you're going to look at the ionic radii, so this is how they look like. So lahat ng mga naging cation, lumiliit sila. Lahat ng mga anion, lumalaki. All you need to do when a cation is formed, its ionic radii is smaller than atomic radii. When a cation is formed, the ionic radius is smaller than the atomic radius. When an anion is formed, the ionic radius is higher or bigger than atomic radius. Okay? Hindi ko na ano ito. Now, the next thing that we can look at these trends is the so-called ionization energy. Now, ionization energy, that's the amount of energy to remove an electron. Okay, so usually they said from a gaseous atom in its ground state. So as you could see here, so you have an atom. So if you want to remove an electron, you're going to apply an energy, and the one ionization, the one associated with that is ionization energy. So energy that you need to ionize an atom. Okay, so it can be, if you remove the outermost electron, is the first ionization energy. If it's the second outermost, is the what we call second ionization energy, and so on. And the thing here, as you remove more electron, you're going to need higher ionization energy. Okay, so if you're going to look at this, so as you could see, okay, the number or the value increases as you remove more electron. And sometimes you could see that it doesn't really have a what we call a sequence. Sometimes the changes is what? Too large. For instance, this one. Hindi mo pwedeng sabihin, okay, first ionization energy, yung second ionization energy doubled than the first. Okay. So here you could see this one, Li. So you could just need what? 520. So what is Li? 1s1, 2s1. So to remove one electron, you not 1s1, 1s2, right? So you only need 520. But if you're going to look at the second energy, it's what? More than 10 times. Why is it? Bakit mas malaki yung second ionization energy than the first one? Because you are disturbing a stable system. So 1s2 parang ano yan, yung noble gas configuration. So to make it 1s1, you're going to need a higher energy. So for instance here, He, so that's just 1s2. So if you're going to remove, okay, to make it 1s1, this is the amount of energy. To make it 1s0, you're going to need a higher energy. So when you are breaking, okay, or removing an electron from the one that has the same configuration as that of the noble gas, like S2, P6, you're going to incur, or you needed a lot of energy. See this thing? 3,660, and then the next one is 25,000. Okay, because you start with what? 1s2, 2s2, 2p1. So when you need to remove this one, this is the amount. You need to remove one of them, this is the amount. If you need to remove one of them, this is the amount. But if it's already in the 1s2, the amount is so large. Okay? Now, if you're going to look at the trend, you can associate the ionization energy with what? The atomic size. Okay? So if you're going to look at trend, so what you have here, H and then He. So from left to right, and then lithium from left to right. Okay? Then this from left to right. So we could say from left to right, ano masasabi niyo sa ionization energy? It increased. So how do you associate it with the atomic size? So the smaller, okay, the size, the larger the ionization energy. Kasi mas stable yung maliit, di ba? So mas kailangan mo ng mas mataas na energy. Although you could see there that there are somewhat anomaly there, but you have to make sure, because what? This is a transition from S to P. Kasi napuno na yung S2, so P1. Tapos ito naman yung transition from what? a P3 to P4. So you have it like this. So ito muna, right? Tapos, yan. So meron a little bit anomaly. But if you're going to look in general, it is increasing. Now, how about the top bottom? What do you think happened to ionization energy? So as you relate it with the atomic size,
Parang,
Lower energy needed
sir,
po.
parang yun sa
it decreases.
pag-apply ko ng water, i-scale up, parang mahirap na po siya.
Okay. Now, you might say, why is ionization energy decreases in a bigger molecule? It has something to do with the attraction of the outermost electron. So parang hindi naman sila close eh. So madali na lang silang tanggalin. Ay baba, hindi tayo close. Unlike if you have a smaller atom. Napaka-close nila, so kailangan pwersahin. Okay? So yun yung, I would say, the main trends that you need to know here. So if you're going to look at the trends here, so there's an increasing ionization energy pataas kasi lumiliit siya pataas. And then an increasing first ionization energy left to right kasi lumiliit siya. Okay? Now, yung isa, electron affinity, this is a little bit complicated. But to simplify the thing, this is just the energy associated with the introduction of electron to a system. So this only involves what? The non-metals, yung nagpo-form ng anions. So meron ang stable atom, you introduce the electron. So the energy associated there, that is what we call the electron affinity. So usually, ang involved lang usually dito ay yung mga non-metals. And if you're going to look at this, what we call noble gases, they have a less zero electron affinity. Why? Kasi hindi sila natangkap ng electron. Sabi nga, noble gases, they're already stable. Okay? So if you're going to look at this, the way that you have it here, okay, the smaller the atom, the higher is the electron affinity. Kasi pinipwersa mo rin siya, okay, punta ka dyan sa electron na yan. So if you're going to look at this, medyo ano lang dito, anomaly. But if you're going to look, I think there's a thing here. From left to right, it increases. Okay? So usually there's a diagonal relationship on the periodic table. I think the thing that you need to know is just, we could say, yung definition ng electron affinity. Okay? So I think that's all that I need to what we call talk about today. I'm not going to go on with this different group. Yun lang usually yung involved. Maiksi lang tayo. So we're done with module 1. Okay? So module 2 na tayo next week. So I'm going to again post in the Canvas, yung link doon sa lecture ko. And again, there are 2 chapters that is involved. So next meeting, ang pag-uusapan natin ay yung tinatawag nating one word. Saan na yun? So we're going to talk about bond. Okay? Ionic bond. Taken, but not sure. So we're going to look at the different theory, at what we call bonding. Okay? So question. Yes, Franklin.
Sir, pwede pong magpa-explain po nung ano po, yung sign convention po kapag in terms po sa electron affinity po.
Medyo magulo yung electron affinity because it only what we could usually involve the so-called nonmetals. Because you don't form an anion in metals. Remember, the electron affinity definition is yung energy na associated doon sa pag-form ng anions. You're adding what we call the electrons. So in some,
Okay.
it is negative. In some, it is what we call positive. And usually, I try to set aside this what we call explanation here. Kasi if you're going to look at, I think the one that you can look at this is ito. Merong isang ano dito. This one. So if you're going to move what? From left to right, so you could see it increases. But medyo magulo siya. Okay? So, anong pagkakaiba nito? So you have the S going to the P. Right? So if you're going to look at the S, usually yung first two ng S nababa lahat, di ba? H, and then the Na, and then the K. Okay? So it has something to do the shift from the S orbital to the P orbital. Tapos pagdating doon sa next one, ano, if you're going to look the Li here. So pag nasa P orbital na siya, okay? Ano nangyayari? Yung first three, ano din siya? Nag-i-increase, and then all of a sudden, from P3 to P4, nag-i-increase na siya. But usually, nasaan ba yung tinatawag nating non-metals? It's usually in the what? P3 to P5. And if I'm not mistaken, there's what we call the trend that I have in my recorded lecture. So paano ano yung unusual trend nung tinatawag natin electron affinity.
Thank you po, sir.
So ang ano ko na lang sa inyo dito is just what is electron affinity. In terms of the trend, I think you could say from left to right it increases. Yun lang yung general trend as seen here. Okay? And from top to bottom, you can consider that they decrease. Parang ionization energy lang din. Okay? So, parang explanation dito, the smaller the molecule, the more stable they are. So, the harder for them to become what? Cation and anion. Kasi yung isa tinatanggalan mo, di ba? Tapos yung isa dinadagdagan mo. So if the system is really stable, you're going to spend some amount of energy, either sa pagdagdag or sa pagtanggal ng electron. I think that's the summary of that ionization energy and electron affinity. That's why the trend is similar. There are still other trends, what we call trend, like left to right, the non-metallic property increases, okay, or right to left, metallic property increases. But I think the way that we do it, we are able to cover. And I want you to look at the solved problems in the module. Okay? So I tried to put the material, I mean yung link doon sa bonding, and then we will continue. We might continue on it because sometime, maybe in 2 weeks, I will not be able to meet you. I have to give a talk, okay, in one of the university there during that time. Baka masagasaan yung schedule nyo. So, we might not meet on September 29. Some university invited me there to give a talk, and it starts from, I think, 9 to 12. So, hindi talaga tayo makakamit nun. So, question. Pwede ko nang buksan? Yung quiz?
Sir,
Hmm.
Yung sinabi niyo po ba kanina yung sa hindi po makakamit, next week po yun ng Tuesday?
No, 29 September.
Okay. Sige po.
So we're going to proceed with module 2 next Tuesday. So I'm going to send you the link. I'm going to post in the announcement the link doon sa lecture. Okay? So, pero yung main source naman ng ano natin ay yung tinatawag nating module. But I just want everything to be, at least you to be more prepared on doing the thing. Okay ba sa inyo yung setup natin so far? Mag-thumbs kayo. Maybe magpakita na rin kayo. Hindi ko, ang iba, hindi ko pa kayo nakikita. Para hindi ako nagsasalita sa wala. No, sinasanay ko lang kayo because most of you are freshmen. Kasi pag sinanay kayo, yung parang dati na, oh, we only meet once a week. And I think some other Chem 18 are doing that. But I think for me, kung kaya ng katawan ko, okay, we're going to meet even as short as what, 30 minutes, we're going to meet. Just to make you, parang lagi kayong handa. Kasi kapag hindi tayo nag-meet up, hindi naman tayo mag-meet. So, parang mag-aano kayo. And it's not a good practice, lalo kung freshman kayo. And remember, we're shifting more on a face-to-face. So, sino ba sa inyo dito based sa Los Baños, nasa LB ngayon? I-thumbs nyo, or at least yung hand. Diba? So imagine nyo na lang kapag nag-aano tayo dito, although it's really impossible for me because as you know, andito tayo sa sa States. So yun yung advantage ng face-to-face. You can have a teacher that's not there in LP. But I've been teaching there before. I think hindi pa kayo nag-e-exist. I was there 99 to 2005. So I don't know kung tao na kayo nun. So tanong, so I'm going to open and see if you can see the quiz. So I'm giving you until what we call 11:30. It's only 10:41. And I think it's a 5 question that is 10 minutes. So kita nyo na? And please, kapag nakita nyo na mali yung recording or I think somebody said, yung isang recording natin, yung part 1 at part 2, pareho lang video. Tell me. At least now, isa lang yung natin, hindi na tayo sinisipa sa Zoom. But please tell me, I mean, I always accept my, na nagkakamali